We are here for another edition of Community Conversations for Technomatics. This is our virtual user group, and today's topic is material flow analysis and statistics. As many of you know, our speaker is Stefan Bongsau, and here's a little overview. He is a freelance simulation expert. Stefan has been in this space for a very long time. He has completed hundreds of projects and training sessions. He's been doing these sessions with us in Siemens PLM for about 2 years now, and he is working on his 6th book on plant simulation. 5 are published and 1 is still in the works. So we're always glad to have Stefan here with us. The big steps for today that he's going to go through are showing objects data collection, the charts, displays, and variables for this, sand key diagrams, data collection using the EndSim method, and then hourly and daily statistics. So as mentioned, we will be having a live Q&A via hand raise, so just stay with us. You can, again, put questions in the chat, but feel free to also just ask a question verbally at the end. That is all for me and my introduction. So Stefan, feel free to steal the screen.
Today, I want to show some topics, demonstrate some topics about statistics. And this is really a big topic. It's within 30 minutes, I can only show some elements and some basic, some remarks from my side. Many elements that I use to create statistics are limited and available for professional license only. For instance, here, the generator or the time sequence is only available for professional license. And the same is for the HTML report. And today I will show you all this stuff without these elements. So you can follow also if we have only the foundation license or only the standard license. It's a pity that is restricted, but you can make a workaround for all elements that are restricted here in plant simulation. And some of these workarounds I show you today. We have 100 hand raise here. Okay, first I create a very simple model for demonstration. I need a source, a station, a buffer, another station, another buffer, another station, and at the end, a train. I connect all together and some basic settings. The first station has a cycle time of processing time of 1 minute, 10 seconds. I restrict the capacity of the buffers to 100 for both. The second station has a cycle time, processing time of 45 seconds, and one availability of 75% and 5 minutes MTDR. And the second station also 45-second processing time. Failures 75% availability and 1 hour MTDR. So we have some statistical values for evaluation, and then I set an end in my event controller of 100 days. And the statistic reset of 1 hour. So these are my settings. And then I make a simulation run. I'll click is finished here. So plan simulation collects really a big amount of data. You can check this very fast. For instance, if you press the key F6, then you get the statistics of all elements in one window here, and you can print this, save this. Here we have already the statistics about the stations, but this is not really nice looking, and so you can make it in another way. You find the chart in user interface, and then you can type with the right mouse button on the chart, and there's a statistics wizard. Here you need to select, okay, what kind of statistics you want to have. I only want to have the resource type production. And if you click OK, you see, okay, train and source are also production, and so you can correct this. This is easier to select all the elements here that you want to have in this window. And then you have a chart about all the stations, and you can make a chart with all the buffers and so on. Okay, so these are some elements out of the box. I guess you know, you have in each station you have a tab statistics, where you can find some of the statistical values. If you go inside of in the attributes and methods of the station, then you find a lot of attributes or values starting with stat. And these are all the statistical values, and you find this in each element in plan simulation, and you need to look, okay, what kind of data this element collects. You see some is 0, 0, 0. Then you it's set up. We don't have set up, and we don't have resources. We don't have workers here, and so you have a lot of empty elements here without any values. But here you have all the values you can read and display, for instance, in the frame. Okay, as first step, I want to have the average stock in this buffer. And there are several ways to collect this data. So one way would be, okay, I use a chart to collect data. The element, the original element for collecting data in plan simulation is the time sequence here. But this element you only have if you have the professional license, or above with Blend Simulation X. And the same functionality has a chart. And so I place a chart here. And I want to plot these values here with a certain interval. And so I just drag the buffer here onto the chart. And you can select resource statistics. I don't want to have the resource statistic. I want to have occupancy. It's a num_mu here. And then you have two different kinds of data sources for a chart. One is input channels, and the second one is a table. And here you have buffer num_mu. This is automatically inserted here into this table. This records now this chart. And mode, I want to have sample. Watch would be collect a data point when the data changes here. Plot, it's the same. And sample, you can select, okay, I want to have every 10 minutes, I want to have one data point. And here's collect data. It's by default selected. And display, I want to have not a histogram, I want to have a plotter and line. And for the plotter, you need to adjust the x-axis here. It's only 1 hour by default. I want to have 1 day, and I need much more values, maybe 100,000. And here I make a star, so it have a flexible range. I want to a feed rate only of 1 and a scroll bar. Okay. These are the steps. Here is my plotter. It's still have the labels from the histogram. X-axis is time. Y-axis is num_mu. Okay. So now I can run the simulation, and this plotter is now collecting all the data. And now you have the possibility to read this data from this chart. And this you can use, for instance, to make calculations, to export the data to an external program, for instance, Excel, or to Python, or to Power BI, where you want to make your evaluations. And this you can do in NSIM method. The NSIM method will be called at the end of the simulation. And I need a data table for this. I name it chart 1. So it formats the data here if we export the data. And I want to have one variable for buffer 1. Mean inventory. It should be real. And 0 is Okay, step by step. Chart 1. I hope it's chart 1. Only chart. No, chart 1. Chart 1. Put values into table. Into table. This is the command in SimTalk to read the collected data from the chart into a table. And we need to hand over the data, the table. It's a chart 1 data. So let's have a look what Plan Simulation delivers here. So I let the simulation run until the end, and then the end sim will be called. And then you have a table. The first column is the time. And the second column, you have all the data that Plan Simulation collects here for you. And this is quite the same like the time sequence would be time, and then here the value in the second column. And now you can export this data here from this table, or you can calculate the buffer mean inventory from here in the NSIM method. And to calculate the mean value, you can use you need this, the sum of all values and the number of data. And so it's sum. We need to specify the range. It's in the second column. We can skip data here also if you want to do this. And chart 1 data point ydim is the number of data points I have for my calculation. I can also run so it now calculates from this data. The mean value is 21.37 and a lot of digits, and so I can round here in my method to digits. Okay. You also can calculate this directly from the buffer here. The buffer collects as statistical values the relative occupation 21.37%, and based on maximum capacity of 100. So you can calculate directly the mean inventory in this buffer by multiplicating the relative occupation with the capacity of the buffer. But this is one way you can collect data in Plan Simulation without the time sequence. You can just use the chart object. So we have a lot of elements to show some values here in a plan simulation for statistics. For instance, you can use the display to display data. And I want to show, for instance, here the relative occupation of this buffer. And so I can, here you have 3 points, and here you can select a path element. Here it's a buffer, the buffer, and then it shows all elements of the buffer you can display. And I want to have stat relative occupation. That relative occupation, okay. And then you need to yeah, write something in front of it's a relative. And then I click on apply. Here it's the same. You can change this value permanently or every 1 minute. If you have variables here, you don't see the changes of variables if you run the simulation. It's better to have a display and update the display every minute, for instance, and then you see the changes in these values. If you have a variable, you don't see the changes in the values anymore. If you stop the simulation, then you see the actual value. But if you want to see the value changes, then the display works better here. Okay, and now I have a lot of digits here, and you can, it's like programming. You can program here in this path field, and you can round, for instance, here the value round. And now I have a round value. So, and you can also make more complex commands or statements here in this path field. If you can add something, you can calculate here. And so you not only can show single values from stations here in the display, you can also show more complex results from statements here. Just try it out. Okay. Another way would be to restrict here the decimal places, but I wanted to show you can also type Simtorq code here in this path field. Okay, the display. If you have some experiments, if you have used 2D for longer time, then maybe you know the display panel. In 2D, this is a way to show a lot of values near the objects. The display panel doesn't exist in 3D. Instead, you can show variables, user-defined attributes here near the elements. For instance, I want to have here the blocking rate. I want to show the blocking rate here at the station. And so I can create a user-defined attribute. I name it blocking rate as a real value. And then you have starting from 2404, I guess, you have one tab display here in this user-defined attribute window. First, I click show in 3D, and then I need to set some display values. I want to have only 2 decimal places, and I want to show this user-defined attributes externally. Okay, apply. And then normally you need to change the position of this element. I open this in a new 3D window. Okay, then you can mark this variable, and then you can change the position, for instance, using the direction tabs on your keyboard. And open dialog here. There you have also a dialog for this display field, and there you have a transformation, and then you can change the position, and you can rotate this and make it smaller or bigger if you want to do this. Okay, so this is the replacement of the display panel, so you can collect all your data you want to show into user-defined attributes, and then show this user-defined attributes near the station. You can organize this here, and you have for each main element a block, a display panel with all the important values. Okay, then you need to trigger this change. I want to use entrance control for this. And there I need to set the blocking rate for the station. And this is just start blocking portion from the standard statistics values from the station here. And now if I run the simulation, you see the values changing, and so you can bring all statistical value you need here near the station. So another way, what you don't have here in this stations are, for instance, some time-based values. For instance, if you need to display jobs per hours or jobs per day, then you have in the train already some statistics. In this type statistics, you'll find throughput per hour, throughput per day, total throughput. So the sources, the trains are the most important collectors for statistics for the complete frame. But if you need to measure the jobs per hours in between, then you need to calculate this by your own. And normally I would use from the information flow the generator, and would call a method each hour to calculate the jobs per hours, but not today. I don't have the generator in my foundation license, and so I need to create my own generator. And first I need some variables. I want to have the jobs per hours of the station 2 here. And I create some variables, jobs per hours, station 2. I need to remember the old value at the start of the hour. Okay, and I want to record the jobs per hours into a table. And it's only some integer values I want to record here. And I need a method to calculate the jobs per hours. And this method I call the first time in the init method. I guess you know the init method will be called by the event controller at the start of the experiment. Or better, the event controller calls all methods with the name init in your frame and in your stations and your elements at the start of the experiment. So you can have a lot of init methods. And within the init method, I call I just first delete my table, the content of my table, and then too much with get H and execute. No. CoreGen. So I called this method at the first time in the init, and then I call this method inside this method again and again. And the calculation is quite easy. I need to consider the reset time of the event controller, because I have set statistic reset time, and I need to collect the data after this time. So I need a condition if event controller sim time greater equal the event controller start. Event controller will reset all the statistic data, so we get some unclear data. If we set this back to 0, I want to use statnum out, and after 1 hour, the event controller will set statnum out back to 0, and then my calculation will go wrong here. So I calculate the jobs in this hour by reading statnum out, the value of statnum out, and I subtract from this the old value from the previous hour, and then I need to reset my old value. And I write the value into my table. And in the end, I need a recursion. And in SimTalk, we execute in. This is the command, and after 1 hour, I recall this method, and so I can create here my jobs per hour calculation, and this replaces the generator. Same function, and I run the simulation until the end. Here I have my recordings, and this is quite easy to evaluate. I take chart, then I just drag the table on the chart, and then I only need to change the data into column. Okay, and I have a lot of values here. And so you see it's flickering a lot between almost 0. If I have here a failure and it takes 1 hour or longer than an hour, I don't have output in this hour. And I have a lot of outputs in 80 here, 80 jobs per hours. And at the end, we have 50 jobs per hours here. And this is, for instance, if the target was for this line element 50 jobs per hours, then it's fine. But if you now have an element here, the train, for instance, so I can have a look here, type statistics, the mean of how much is the time for 50 jobs per hours. It's 74 seconds. If I set here 74 seconds, maybe you have the target of 50 jobs per hours, and here's some conveying element, and you you plan this conveying element for 50 jobs per hours. And if I now run the simulation and have a look at the type statistics, then it's only 37 jobs per hours. And this is one failure I have seen in so many projects. The mean jobs per hours, it's not the right performance indicator for calculating the necessary the capacity necessary here in the next elements, because Now it's only 50. Without this restriction, I see I need for the next elements, I need 80 jobs per hours as a capacity for the next elements to reach 50 jobs per hours in average. And so it's very important to know, okay, what's the peaks I have here in my jobs per hours. And so we need I got these values here, and this is sometimes very hard to explain why you need here 80 hours, jobs per hours, when the complete line should deliver 50 jobs per hours. But if you have such, errors, failures, then you need to run faster to get your 50 jobs per hours. Okay. So this was only a small fraction of statistics. I will offer some more webinars to show, okay, some statistical elements outside of the standard statistics of plan simulation. For instance, a Gantt chart based on a table, or a Gantt chart with Python. These are also some webinars that I will offer this year. Okay, do you have questions?
First one, it's from Mehboob. How do we reset statistics for multiple simulation runs?
Okay, you need to clean up your tables, because the tables are not cleaned automatically. Would be very hard if you have data that you need for each experiment. The basic statistics are reset by plan simulation automatically. And if you want to save some data between the simulation runs, then you need to write it into tables. Okay, why do you need the ANSYM method? The ANSYM method is a method that is called after the simulation gets to its end. The end you set here, and then it's calling the ANSYM method, and then you can make all calculations you want to do for the complete after the completion of the experiment. This is a standard method in plan simulation, like init or reset. There are 3 standard methods. Are data tables available for standard license? Yes, they are. What is not available is list data types. You have several list data types. It's data list, data stack, and data queue, and these are not available for the standard license. Data table is available for the standard license. Is it possible to plot machine statistics for multiple machines within one chart element? Yes, just track them all together to one chart. Here it's input channels, and if I track the next buffer to this chart, then I have, okay, normally okay, I can copy this here. Buffer 1, normal mu, here buffer 1, and then it plots. I hope so. It plots. I hope you see this. Now it plots the values of 2 buffers in one diagram.
I'll take everyone's hesitation as a moment to share slides. This is a link which you can click on if you like to the virtual user group area in the PLM community forums. And if you go there, the image is showing that we suggest you follow the topic. So you go to the link, click that button that says follow, and then click the small envelope icon to select every post. And then that makes sure that you'll get system messages when we post the recording on Friday, when we post the next registration link. If you are following and select every post, you'll be notified immediately. The next sessions are value stream mapping on February 25th. You can click there to register today, and cost simulation on March 11th, which you can also click to register for that one today. So we'll have a different speaker on the 25th, someone from PlantSim AG, and then Stefan will be back with us on March 11th. Looks like we had another question come through.
GBH calculation can be more complex when there are calendars with shift turned off, pauses, yes. And for each key performance indicators, it's really important to have a common understanding with your customers, what you want to see. And you can use the calculate walking duration method from the shift calendar to calculate the shifts per hours depend on the working hours. And so, yeah, it can be very complex. If you wanted to reduce the blocking rate shown, would the next step be increasing buffer capacity or decreasing the cycle time of the downstream station? Oh, yes. You can also try to change the availability of the station too. If you find a way to shorten the main time to repair, then it also will reduce the blocking rate. Normally, if you have not an endless buffer capacity, then it's hard to optimize the blocking rate, because blocking rate means the bottleneck is after this machine, and there's a bottleneck analyzer here in Plant Simulation. You find it in tools, bottleneck analyzer here. And then I just show the analysis, and you see here it's this one is the bottleneck. You see it also here. Station 2 has almost all is failed, and there's no waiting time, almost no waiting time here in this station, and so you have the bottleneck at the end of the line, and so you have a blocking rate. Yes, you can try to reduce the cycle time here to empty the buffer faster, and this will reduce the blocking rate. Yeah, there are several ways to do this, but you need to check it in reality, what is possible.
Looks like one last question. Stefan, do you see it? Where he said, how are the display labels like the net occupation percentage being updated? Are they using an observer or a generator?
The displays, they update by themselves. There are two ways. You can set an interval, so you don't need a programming for the display. You only need to select the mode of the actualization. It could be a watch, but if you want to use watch, it works. Should be an error message. Doesn't. This is not watchable here, this statement, and so you cannot use watch for this. And so you can only use sample. But if you have an observable value here, then you can watch, and then it shows every change in the display, but it's automatically. And you can also show here some bar or pie if you have, for instance, the occupation, and you want to show the occupation based on 100%, then you can change the display to a bar or pie here. But it's no programming necessary here. I don't think so.
Is this your answer to using a percentage symbol at the end of the display path?
Yes.
Okay.
You can, one moment, you can change this to a string, but I don't think to a string. And then you can add a percentage at the end, but I don't think it's worked. It works, yes.
One of these days you have to come off mute, Luis. You said 5 years to discover this. That's cool. So very quickly, if you're new here, I always mention if you want some comprehensive education, like on this topic in particular, it's a big topic, check out Siemens Accelerator Academy. That's where we have like official courses from A to Z. You can click through the links that are on your screen there. There's also a plant simulation associate certificate if you're very new to plant simulation. And the other thing is Realize Live. Every year, Siemens puts this on for the software users in Americas, Europe, and APAC. So you can see the dates that are there. You can actually click on those links if you want to learn more on one of those locations. The early bird registration is open this week, so I have to update that next time we meet. It will be regular price. So that's that. Stefan will definitely be presenting there, and I'll be there running a booth at both America's location in Detroit and in Amsterdam in Europe. So we'll both be there. So we still have 2 minutes left for questions. You can see a link to Stefan's community profile there on the screen on the slides. And then of course, the link to the virtual user group forum. The recording will be available on Friday. So that is all for me and announcements. Yeah, we've got a couple of topic suggestions and some applause.
Very nice.
Yeah. Well, Stefan, it's always a good session when you get in here and explain some stuff. And I love to see like long-term users getting some tips and tricks they can use right away. So always a good time. And then if there's no questions for now, you can always ask them in the forum. So you can mention Stefan under this recording, which will be available on Friday.
Thank you.
That's all. Well, yeah, we'll see you in the forums. Bye, everyone.
Goodbye.